An energy conversion is a change from one form of energy to another. So, this example here is what we do with a light bulb. A light bulb is a way to perform an energy conversion. You take electrical energy, which is electricity, it enters the light bulb, and the light bulb itself converts that electrical energy into light energy and heat energy, or thermal energy. The light energy is really what we want from the light bulb. The heat is wasted energy, which is why light bulbs are not as efficient as we would like them to be, because they produce a significant amount of heat, which is why when you try to change a light bulb, it burns you if it's been on for a long time, because that light energy, to produce that light energy or to convert the electricity to that light energy, produces also some wasteful energy, which is the thermal energy. Also, here you see a match. There is chemical energy stored in the material that is on the tip of the match, and when we apply a little bit of heat to it by striking it, we create friction or create some thermal energy. It sets off the chemical reaction, which converts the chemical energy into, once again, light and heat energy. And sometimes the heat energy is wanted when using a light, and sometimes it's not. So we have machines in our lives that convert energy or perform these energy conversions for us. Here you have a heater. This is a gas heater. It takes the chemical energy that is in natural gas and it converts that into light and heat energy. Here is a toaster, obviously. It's going to convert your electrical energy into, once again, light and heat energy. Now with our gas here, we're going to feel that radiant energy, that heat. We want that heat as well as that light. Here we also want the heat, but we don't really need the light energy that's produced, so some of it once again is wasted. We use that heat energy, that thermal energy, to toast our bread. Here we have a windmill using the mechanical energy of the wind to turn this turbine, which is going to convert that mechanical energy of the wind into, hopefully, electrical energy. And here's another windmill, which is going to use the wind energy, once again, that mechanical energy of the wind, and turn it into the energy that we need, either electrical energy or convert the mechanical energy of the wind into more kinetic energy, mechanical energy, to maybe turn the stones in a mill to grind wheat for bread or whatnot. It can convert the mechanical energy of the wind into other mechanical energy that we need. Still energy conversion. So, as we stated before, the law of conservation of energy tells us, much like the law of conservation of matter, that energy is not created or destroyed. Energy only changes forms. It is converted from one form to another. But we do not lose energy. We just may convert it to a form we don't want, but we don't lose it. It is definitely still the same amount of energy. So whenever we convert energy, there is some unwanted energy. Okay, one of those major forms of unwanted energy is the thermal energy created by friction. Friction is that oppositional force. It's opposing all motion. So every time there is friction, there is some thermal energy produced, and it is often wasteful. We do not want it. If you want to feel the thermal energy of friction, you can take your hands and rub them together very quickly. That friction will create thermal energy, and you can feel it for yourself. All energy conversions create some sort of thermal energy. Sometimes, once again, we want that thermal energy, and sometimes we don't. It will be very helpful for you to be able to identify energy transformations, such as here we have chemical energy that is in food, and our bodies are the machines that convert that chemical energy into some sort of kinetic energy, energy of motion. Sometimes we have the radiant energy of the sun that is converted into chemical energy by plants. Radiant energy is another name, once again, for light energy, and it is converted by plants into chemical energy, which once again later on we may eat, boom, and convert into the energy of motion. The chemical energy held in the chemical bonds of gasoline is used by our car to convert that into the energy of motion, that kinetic or mechanical energy of motion. And then many of our utilities in our homes convert electrical energy into all kinds of energy. Here's a stove. It's going to convert electrical energy into thermal energy, and obviously a little bit of light energy. As you can usually see a stove working, you can see that energy of light, some of it. And that is all for today.